In this video, I will show an interesting application of the fundamental theorem of calculus. So let's take a look at this problem. We have a function f, which is an integrand of another integral function. So we can think of function f as if it is defined implicitly. So that means in order for me to evaluate it, I will have to do something to get that function out of this integral. And one thing that we may consider is the differentiation. So let's differentiate both sides of this equation. And we're going to differentiate both sides with respect to x. So on the left hand side, we simply use the product rule. So what's the derivative of x times sine pi x? It's the derivative of x times sine pi x plus x times the derivative of sine pi x, which is cosine pi x times pi. On the right hand side, I have to use a combination of the fundamental theorem of calculus and the chain rule. To summarize that, it says that derivative of a function defined by an integral like this is simply f of g of x times the derivative of g of x. So this is the rule that I'm going to use to differentiate the right hand side of this equation. So instead of f of t, I'm going to plug in x squared for t, and then I have to multiply everything by the derivative of x squared, which is 2x. And now, while we still don't know what f of x is, we can find f of 4 by simply setting x equal to 2. So we have sine of 2 pi plus 2 cosine of 2 pi times f of 2 squared times 2 times 2. And you can definitely simplify everything. Sine of 2 pi is 0. Cosine of 2 pi is 1. So dividing both sides by 4, we get pi over 2. So f of 4 therefore is equal to pi over 2. So this is the answer to the question.